This video is going to demonstrate the creation of the cam lever from the drawing file provided here. It's a relatively simple part, but what throws a lot of people off is the cam surface, the series of arcs here. So I'm going to show you how to create this object. Please do try it before you follow step-by-step directions. That's a skill that we do need to develop. Let's go ahead and get started here. All right, so I've got some things going on. Right off the bat, I think I'm going to want to do a center line from the origin where I'm going to put these series of circles and the cam as well up to this point. And I have a distance that's going to help me size right off the bat. There's my center line. I'm going to put my dimension in it right now, 2.878. Okay, what do I have here? I've got straight line, I've got some arcs down to 2 lines, and overall on this end it looks symmetrical. So on this top line I'm going to put a midpoint right off the bat. Okay, got some arcs here. I could, I guess, come back and do work with my computer. I could probably corner it and come back and put a fillet in there, but I think it's just as easy to do this. Okay, and these don't necessarily come to the same endpoints, and they are not the same length, so got to be aware of that. I do have a dimension here, 0.551. Looks like it's between the 2 center points. Oh, what happened there? Talk about going goofy. And do that. You see I'm missing a tangent here. Oh, that was interesting. Okay. So before I do that, hold on here. Let's put in my radius on both sides. There's 0.1. Since that's what's going absolutely nuts when I put that dimension in. This looks very horizontal to me. Now let's retry that 0.551 and see if it goes nuts again. All right, something's going a little crazy, but we'll figure it out. All right, I'm not going to worry about it right now. I'll come back and do it later. Okay, on the bottom, I've got a circle. And then I can see here 3-dimensionally that there's a step down. I'm going to have to come back and cut that as a second step. So I'm just worried about the smaller hole right now. The diameter of that smaller hole, according to this, is 0.76. So I'm going to put that in there. And do make sure you get your diameter and radii correct. And these are diameter callouts. That 1.02 is going to have to be a second step because it's a cut. Could put it in now and share the sketch. Just make sure you don't mess yourself up doing that. Now for the detail B, which is the zoom in of this part here, for this cam, I've got several dimensions, and these are all aligned. So I have a distance from here to here, essentially the start of this cam. There's one that looks like it goes right along the horizontal axis, one on the vertical axis from the center point to the bottom surface, one on the other side of the horizontal axis from the center point to the outside or right side, and then one to the end. So I don't know, what is this, a 340 or 50 degree series of arcs? So the best way I think to do this is to make a bunch of construction lines and put in all those dimensions that I'm given. Okay, now when we dimension, make sure you get the aligned dimensions where you have perpendicular lines coming from both points. This would not be a good thing. This would not be a good thing. You want that aligned one. And you may have to roll around to find it. 0.625, 0.656, 0.718, 0.781. The last one is 0.831. These actually do connect. Okay. I'll worry about that later. It needs to get skinny, but we can do that later. All right, so I have these points, and actually the ones on the axes are constrained. The only ones that aren't are these, but when I get the rest right, it should hold it together. Let's grab the 3-point arc. I could probably use a tangent arc too, but let's start with 3-point. And I'm just going to connect here, get rid of the construction. I don't really know where these are supposed to be yet, so I don't know, just somewhere in between. One thing I do want between the series of arcs, not necessarily at the endpoints, but between the series of arcs, is a tangent. That is going to be a good thing. Although it's going to look goofy at the beginning. And I can just as easily put that in later too. All right. Now, okay, so do need to go figure out the top part now. All right. I'm going to try and put this in, and if it doesn't work, I'm going to delete stuff. Since Fusion does this quite a bit. I'll delete that and see if I can put it in. No. Okay, let's delete these guys. Shouldn't have to delete the tangents. We will see. Boy, it doesn't like me at all. Bye-bye midpoint. Good gosh. Okay, I have to delete the line. Sometimes things get goofy. Let's try this again. It's a fun one. All right, let's delete it all. Something did not work out very well there. Let's bring them in closer to where they're supposed to be. I can dimension. Oh, no, I can't do that. All right, another line. We'll try and recreate this, and hopefully it will follow the rules of CAD after that. We know this is going to be tangent because everything looks so smooth. All right, let's try and tangent on the bottom again so it doesn't go bonkers when I put this in. 0.551. All right, now it's cooperating. Okay, also, I need to put in those dimensions I got rid of. And this was 2.878. These were R1, 0.1 I should say. 1. All right, much better. And I do want to put that midpoint back in there because this does need to be symmetrical. All right. Let's see what else I could be missing. So these guys need to be controlled. Oh, if I look carefully, there's a 0.185, and that is between that endpoint and the center line. 0.185. And there is one as well on the right side, and that is 0.203. That looks much better. All right. Now, let's talk about this cam circle. So I did, there are not radii, any radius or diameter dimensions associated with this cam. We are looking for this general shape. There does need to be tangents between to make everything very smooth. And we know tangents smooth things out. But here is a non-precise rule I'm going to give you right now. Make sure all the center points are as close to the center as you can get. As you see, the further away the center points of these arcs get, the more goofy it gets. So get them as close as you can to the center, and that will suffice. If you get them within about 0.2 or 0.3 of that center point and it looks pretty round on the outside, that is perfectly acceptable. If this series of arcs has tangent relationships and has a consistently increasing radius, you nailed it. And so the way to fix this is to use the fix constraint and take one of these and select it. And that will provide you a fully constrained sketch. Now, the fixed constraint is not something that we use very often because it's generally not the best way to do to achieve fully constrained sketches. You want to use dimensions and other constraints. But this is a perfect example of a time where a fix is actually a very useful thing, just because of the surface that we're using. Now, this cam is actually going to be used to impart force to tighten our cam clamping mechanism. So we're just looking for smoothness and increasing radius. All right, that is how to create that sketch. So let's extrude it and do the last couple steps. Both of these are 0.123, so if I add those together, 0.123 times 2. Okay, now I just need to cut one more circle in here. Put a diameter. This is a step down circle. This was the one that we didn't put in at the beginning, 1.02 inches. Oh, not 1.2, 1.02. Do an extrude on that of negative 0.123 as per the sketch. And preview looks good. Cut it. Let's look at it isometrically. Does this look like this? I'm going to say yes, it does. That I'm happy with. All right, guys, that is how to create the cam lever. And just remember, don't get too frustrated with this cam surface. It's just a series of arcs that you make tangent to each other. Get it as close as you can, and then use the fixed constraint.